have studied about central processing unit. Okay, central processing unit, it contains three main units you studied earlier. Control unit, it is the brain of the arithmetic logic unit. Okay, it will perform the arithmetic and logical operations. Okay, in addition to that, there are so many internal registers. Internal register nothing but storage elements, just like they will store the instructions actually. Okay, 8-bit, 16-bit, 32-bit, like that. Okay, 8-bit register means it can store 8 bits of zeros and ones, 8 zeros or ones, like that. Okay, so we have studied earlier about control unit and arithmetic logic unit. We'll study more detail about registers, different register storage elements in the processor. Okay, so we'll come by one. So what should you do? It has to fetch the data first before. So what does it processor should do? Processor has to execute the instructions or process the instructions. Okay, first what should it do? It should get the instruction either from input or from the memory. So fetch the instruction. Fetch. Okay. Second, what the processor should do? After getting the instruction, it should decode it. Fetch, decode. Next, decode means interpret, and run the instruction. Run the instruction means process the instruction, and then store the result. Okay, this is the things processor has to do. So for that, how each register will be useful, we'll see that. So fetch the instruction. Okay, for fetching instruction means it has to fetch from the memory. Okay, instruction has to be either fetched from the memory or from the input output device, but it should usually store the instructions in the main memory, so it should fetch from the main memory. So what should it do? So it has to fetch the instructions from the memory. In order to get the instruction, it should have from where it should fetch the instruction. For that purpose, what should it contains? Program counter. Program counter is nothing but next PC. See here, this first one, program counter. PC means program counter. What does it mean? For example, memory, just like take a basket like thing. Memory means just like some storage elements. This one register, this is one box. Like tray, you can take the tray. From which tray it has to get? See, for example, 0, 1, 2, 3, like that. Okay, each one 8-bit. I assume each one 8-bit. Okay, like 5 addresses are there. So program counter, does it contain? Program counter contains from where next instruction to be fetched. So for example, processor is currently running from, it has already taken from 0. Okay, 0, it has already fetched the instruction, it is executing. So what does program counter contains? Program counter is incremented by 1 because sequentially we are executing one by one instruction. Okay, so program counter, what does it contains? It contains the address of the next instruction to be executed. Address of the next instruction to be executed. Okay, every time after, for example, now program counter is here 0, so it will fetch the instruction from here. Okay, after fetching, it keeps on increasing, so but it automatically increments to the next instruction. Okay, so that it can ready to fetch from the next instruction, and currently now running instruction will also run. Okay, so program counter, what does it contains? Sequence of, for example, multiple instructions from where next instruction has to be fetched, has to be get. Okay, for example, it has to get from 1. So after it has taken data instruction from 1, again the program counter will keep on incrementing. It will point to the next instruction, like that. So for the sequence of instruction, it will contains. Okay, so program counter contains from where the instruction has to be fetched. Okay, next, this is the instruction register. Instruction register is nothing but instruction itself. It takes, for example, whatever the data is contained here, it will come to the instruction register. What is this? Memory address register. MER, memory address register. MDR means memory data register. Okay, so these are buffers actually, buffers to synchronize the speed. So for example, program counter wants to fetch from the location 1. It will place 1 here. Okay, so that memory address register will contain 1. So 1 is pointing here. So now it will fetch from the data from 1, instruction data. So it will place in the instruction register. Okay, this is the address location. See, this is address, this is data or instruction. Okay, you have to understand the difference. Address location is different, data and instruction, that particular location is different. For example, multiple houses are there, so each house will be identified with some number, that is the address. Okay, 100 houses are there, you are giving 0 1 2 3 like that, so each house is with one number, that is the address. So data is not inside persons. For example, inside whatever it contains, that is the data. Okay, address and data are different things. Okay, so memory address register will place the address here, so that memory can send the required data from that particular address. So it will take the memory address register data. Okay, so instruction register will store. For example, an instruction also needs data. Data means, see, for example, some instruction addition. Add BC. Okay, so opcode, you take the opcode first. Add address 1, address 2. For example, this is IR, this is instruction, it has fetched from the here instruction register. What does it contain? Instruction register. It is like this actually. For simplification I am telling. Okay, add, for example, add processor is designed add with 0 1 code. Okay, this is from the instruction data 0 1 0 0 0 1 location. This is roughly take, this is some instruction, it is fetched from here. So okay, so computer will understand. So first it will decode opcode. Control unit will take the first. For example, computer is designed in such a way that first 2 units will decide what operation it should do, add, addition, subtraction, like that. Okay, this contains add instruction. 0 1 means add. Okay, like that. For example, I am saying roughly, for example, 0 1 means add, and instruction, whatever instruction we are giving, it should also contain which locations we should add actually. So address of the data A, B, for example, add BC, B location and C location address, from where it should fetch the data. So what does CPU will do, central processing will do, first it will decode the instruction. After fetching, it will decode opcode, what does it says, from where it is, from where the data should get. For example, instruction add is equal to ABC. So decode means, for example, it understands if it is 0 1, it is designed, if it 0 1 means addition operation, it will generate control signals to the arithmetic logic unit for the addition. Okay, before that what should it do? It should get the data means which 2 numbers it has to add. 0 0 means from 0 0 address location, from here again it will place 0 0 here, memory, so here memory address register again. Okay, it is the 0 0 is the address. So memory will give the data, that particular location, whatever data inside the data, it will place here, memory data register. Okay, it will place, it will come to the arithmetic logic unit. Okay, this is like buffer actually, intermediate. Okay, again it will give the address for the next location. I mean, it has to fetch 2 data to addition, 2 numbers it has to fetch. So again it will place the address here, memory address register. Again it will give the data, corresponding data, location, corresponding data will come to the arithmetic logic unit. Okay, after addition what will happen? It will generate the result. So after the final result will be stored in the temporarily in the accumulator. ACC is also final result storing of the accumulator address. Final result will be stored in the accumulator. Like that means accumulator contains, what does it contain after execution? Accumulator contains B plus C. Okay, this is the way it should operate. So but see here, you have to store again this accumulator result into the memory location, because these are all temporary, but execution results will always should store. So again it will, there is in the program, there is again an instruction store, STRO, store. Next instruction will be store at some address. So what are the program counter points will contain next instruction that store this result into the accumulated data to the some particular memory location. Okay, this is the way a instruction cycle runs. See here, this is the heart, how the processor works. Fetch, in order to fetch means it has to fetch the instruction. What should it do? First it should do the instruction. Programs means it contains series of instructions. So instructions it will fetch one by one sequentially, one after other. It will first fetch one instruction and it will execute that instruction. Again it will fetch the next instruction, like that. So first is fetch. So first it will fetch from program counter contains sequential addresses. Program contains where it has to fetch. So first it will go, program counter will point to the address, so it will go to that address and it will fetch the instruction, it will place in the instruction register. So here is the instruction register. It will increment the program counter so that it can able to fetch the next instruction where it has to fetch. Okay, after fetching it has to decode this instruction. What does instruction contains? Instruction, every instruction usually contains what it has to do, from where the data for doing that operation, from where, which locations it has to fetch the memory, data. Okay, so instruction register contains opcode plus addresses from where it has to fetch the data. Okay, so CPU control unit will do? It will interpret the opcode, addition or subtraction, rotation, whatever operation it has to do, and again it will also, this addresses will also, it will decide and it will place this address here, memory address register, and this memory address register will point out to the like houses, which house it has to collect the data. So just like in memory, it will place that address, it will get the corresponding data and it will place in the accumulator in temporary registers. Accumulator also contains, arithmetic logic unit also contains lot of temporary registers, so it will face that person. So after that what will happen? Opcode, depending on the opcode, operation code, addition or subtraction, it will generate control signals so that arithmetic logic unit will perform the operation required, addition or subtraction, on the collected data from the memory, whatever address it points. So and the final results will be stored in the accumulator. From accumulator it has to again go to the memory. So these are the internal registers. What are the internal registers? Memory address register, memory data register, accumulator, program counter, instruction registers. These are the important registers inside. In addition to these registers, there are a lot of temporary registers inside the computer to store the results in temporarily. It changes depending on the architecture of the computer, processor to processor. It depends on the design actually. Okay, types of instructions also will depend on the processor type. Okay, so this is the heart, this is the computer. We study more details about this, all these instructions. So in order to execute an instruction, processor should fetch from the memory, then decode. Decode means what it should do. Okay, what it should do. Decode and it will get the required data from the memory. Okay, and after execution, if it is addition, it will perform the addition, subtraction, rotation. After completion, it has to store the data. It will again from the accumulator, data will be stored. It will again store to the memory. Okay, after the completion of this is the instruction cycle. What will happen after completion, after storing? It will fetch again next instruction sequence. Fetch, decode, again same cycle repeats. Okay, so where will it fetch? Already program counter, it will point to the where the instruction has to be fetched every time instruction fetched, it will increment it automatically. Okay, this way the processor is